as I mentioned above before, there will be different concentration of minerals in that one. Okay, so today if you do one test, tomorrow the mineral content in the water may be different. So this first step is to have a standard water. Okay, so for that one again we have to take deionized water. Okay, now if you may ask, there won't be any minerals, right? We can't put this fish in there, so fish will eventually die. So we need to add calcium chloride, potassium chloride, sodium bicarbonate, magnesium sulfate, again with respect to standard. Okay, so to the deionized water, what we have to do is we have to add these minerals so that the water will become enough with the minerals. Then we introduce the fishes. Okay, and again remember here we need to check for the pH value of the water. Okay, it should not be highly basic or highly acidic in nature, so that it should survive in that condition, right? Then we need to feed only once or twice in a day, because once you start the test, we are not supposed to feed the fish, because these fishes can survive for 1 to 2 weeks without any food. Okay, so again, we have to check two more things, that is the temperature and the oxygen level in this acclimatized water. So we took the DI water, we added the minerals, we maintained the pH, then there is specific temperature should be maintained, and the oxygen concentration level. So once these criteria is taken, we have the fishes ready for the test, right? And also one more thing to be noted here is during the acclimatization period, that is the 1 to 2 weeks, if there are 5% of fishes are dying in this whatever setup we have, then we have to discard the full lot of fishes. We are not supposed to go forward with that, because already there is the standard. According to the standard, we can't do or go forward with the particular test, right? Because more than 5% fishes are died. Okay, so again we have to start from the beginning. Take fresh water or the DA water, add the minerals, add the fish, maintain the temperature, and wait for 1 to 2 weeks. So once the test is done, acclimatization period is done, and the fishes are alive, then we can start the test. Right. Now, how to start the test is a question, right? Directly, should we add the 1000 milligram and check whether the fishes are dying, right? So again, according to the standard, there is a benchmark test. Okay, we have to start with 100 milligram per liter. Okay, so take the aquarium or the fish setup. Okay, into that you add 100 milligram of the sample. Okay, and see whether the fishes are surviving for 96 hours. Okay, so after 96 hours, you have to see whether the half the number of fishes are dying or not. If all the fishes are alive, that means you have to go for the higher concentration. If the fishes are dying, means you have to go for the lower concentration. Why this benchmark test is done is to just see what range the toxicity lies. For example, in 100 milligram per liter, all the fishes are alive, means we can go for the, actually according to standard it is 2.2 ratio multiplication. Okay, suppose you took 100 milligram as the first sample, then second sample should be 220 milligram. Okay, like that. So you have to see in the next whether, that is why the setup is shown here, it is of different concentration. So once the benchmark is known, suppose for 100 milligram all the fishes are alive, then you can take the series arrangement. Okay, one with 100, 220, 440, 1064, like that. Okay, so in that arrangement again you have to observe for, inspect the 6 for certain hours, after 24 hours, 48, 72, and 96 hours. Here every after 24 hours or interval, you have to observe whether any mortalities are there. If the fish is dying, then you have to remove that fish. Okay, but remember, no need to feed the fish during the test time. Okay, and see after 96 hours how many fishes are dying. Okay, suppose you initially had 8 fishes in that one, and 4 fishes are dying, means already it is reached that LC50 value. So that means that is the lethal concentration for that particular lubricant. Okay, and then we can repeat one or twice. Okay, even during the experiment also we can have 2 setups or 3 setups, the same concentration, just to check whether the lethal concentration is achieved or not. Okay, so we did this lethal concentration test or fish toxicity test for all the ingredients going into this cutting fluid. Okay, starting from the base oil, coconut oil, all the emulsifiers, additives we have added to the lubricant, all were tested in this procedure, so that we made it sure that all are having LC value more than 1000 milligram per liter. Of course, there were one or two ingredients which didn't satisfy this requirement, so we couldn't go forward with that additive. So we removed from the list. Okay, we took only those which satisfies this condition. Okay, so this lubricant had only food grade emulsifier and natural additives which are non-toxic. Now you may ask me, is all vegetable oils non-toxic? Oh, sorry, non-toxic, right? So what we did is we even tried with non-edible oils such as Jethrofa and Pongamia. Okay. So what we found that their fishes are dying. Okay. So here the LC50 was more than 1000. Okay. So what we found less than 1000 but around 800, 900. So some, even though it is vegetable oil derived, doesn't mean that it is completely non-toxic. Okay. So it can harm or it can be environmentally not friendly, even though it is derived from vegetable oil. So that was one observation we found. Before that, the intuition was anything derived from vegetable oil will be non-toxic, or a non-edible oil also will be non-toxic. But our test proved that Jethroba and Pongamia was toxic to the fish system. Okay. Right. This is the comparison for different cutting fluid we tested and the GCF. We found that commercial cutting fluid tests for sample 1, 3, and 4, even a minimum milligram per liter, say 40 or 50 milligram sample, if you are putting this aquarium, the fishes are dying. Okay. So these are highly toxic. Only one commercial cutting fluid, that is, that was a synthetic one. So that was showing around 800. Okay. First, all were below 100. So that shows that how toxic these mineral oil based cutting fluids are. So again, this is a survival graph of fishes showing with the days. So you can see for the synthetic, this first one is the control, okay, and second one is the then we have GCF. Then synthetic and CCF you can see here all are going down, right? Because all the fishes are dying within the 2 or 4 or 6 days. And once we did this fish toxicity test, another advanced level of test is zebrafish embryo test. Okay, so we know zebrafish may be sometimes having some good resistance to some of the lubricant. Okay, eventually what we planned is we go for higher order test, that is zebrafish embryo test. Here what we do is we will expose the zebrafish embryo to this metalworking fluid. Here we were exposing fishes, but here we will be going for exposing fish embryo. So according to the ethical terms nowadays, people prefer to go for zebrafish embryo rather than zebrafish itself. Okay. So this test is similar to the what all fish toxicity test. Only thing is we are exposing fish embryo rather than fishes. Okay, so we did 2 replicates for each test. Okay, different concentration was taken. Here also there is a bench test. Okay, to see what regime or what will be the range where the concentration is there. Okay, highly toxic or least toxic. So here you can see this is a well plate. Okay, here you can see the different samples of cutting fluid chosen for the test along with the cutting fluid we prepared. And this is the fish, what you call well plate. So this well plate is having 2 ml capacity. Okay, so what we'll do is we'll add water to this, water the embryos will survive, those water will be fed. And to that we'll be adding this cutting fluid, okay, in the given proportion or the given percentage. And we'll be seeing whether the fish embryo can grow and turn into an adult or become a larvae in this system or not. Okay, so these are very small in the order of micrometer. Okay, so when you see through this microscope, optical microscope, we found that whatever embryos present in the commercial cutting fluid, they were not forming larvae. Even though it is forming larvae, you can see the tail is bent. Okay, it is already dead, right? And we could find that whatever embryo was there in the green cutting fluid, it turned into a larvae or adult fish. Okay, so what happened is that this commercial cutting fluid, due to the toxic or chemical is in that one, it is not allowing the the embryo to turn into a larvae. So again, we did the different concentration studies. Okay, so you can see even concentration of 1% or 2% itself, it is highly toxic. So here is a comparison. Okay, so here you can see a dead embryo. Okay, fully white chorion. So you can see it is a structure like this. Okay, circular structure. So if it is fully white, it is known as dead, or we can call it as dead embryo. Okay. If it is alive, you can see a transparent color like this. Okay, so this outer layer of this embryo is known as chorion. So you can't distinguish where is chorion or the inside layer if it is dead. You can see this is in the case of commercial cutting fluid after 5 hours. In the cutting fluid 5 after 24 hours. Okay, so you can see already the embryo is dead, and you can see the alive embryo. You can because it is transparent. You can see the alive embryo here turning into a larvae here. Okay, so again this is a dead larvae. We could find one or two samples. The embryo was turning to be larvae, but what happened is that eventually it is dying. Okay, it is just not sustaining. Then this is the alive larvae in GCF. Okay, it will be seen like this. And one more study, advanced level of study, is to cross-examine these larvae and see whether any internal parts, organs is affected or not. So that level we didn't go. We just studied whether it is affecting its life or not. Okay, so this is an alive larvae in control. So the inference from what we got from these studies, fish toxicity tests and fish embryo, is that the fish embryo were unable to survive in the system with commercial samples, even at lower concentration. Remember, we had very low concentration for embryo. Okay, even in that level of concentration, the embryos are not evolving as a larva. Okay, the reason we found could be the toxins present in the cutting fluids, and we know the GCF had only green additives, so that is why it is non-toxic and eco-friendly. Now, the third aspect of testing toxicity is to expose to human cells. Okay, so why expose to human cells, skin cell, is because when an operator is working in a machining or production area, so he can get exposed to this cutting fluid via mist inhalation or in contact with the cutting fluid during prolonged exposure. Okay, so when it is the fluid is in the machining area, he may touch the lubricant, he may inhale through lungs. Okay, it can lead to different diseases. So we need to see whether it is skin compatible or not, right? So for that we studied skin cell viability test. Okay. Remember here we can't use normal skin. Why? Because that won't. It is difficult to what you get grow in laboratory conditions. Okay. So in laboratory like microbiology studies, people go for cancer cells. That is called Hackard cells. Okay, so that will multiply. Okay, that will have more resistance. Okay, so those cells were taken for this, or cells were taken for this study. So what we did here is similar to the toxicity test. We exposed the skin cell with green cutting fluid and commercial cutting fluid, right? So what we found that in control means the medium where the cells will grow freely. Okay, it's more comfortable there. It's a fluid for that. And then there is water and there is GCF. You can see in GCF, water and control, the cells were not dying. Okay, it is sustaining. But whereas for commercial lubricant, you can see the cells are dying with the time. Okay, so again, the inference we found from this one is that this commercial cutting fluids is having highly toxic components. Okay, so this commercial cutting fluid failed in the fish toxicity test, fish embryo test, and finally in the skin cell viability test. Here you can see little upward and downward trend. Okay, this is because these cells will multiply. These cancerous cells will multiply. That is the way why it is showing the variations. Right. Now again, we found that there is toxic components, what you call, uh, it's not, we didn't get any solid proof, but it is like qualitatively we can tell there is toxic components present there. But quantitatively, how will we tell whether it is toxic or not? So we need to have some analytical method, right? So we used here GCMS, that is known as gas chromatography mass spectroscopy. Okay, so all the samples we took it to this test. Okay, here this test is done to see what are the. This is nothing but we'll break down this major compound and see we'll classify based on the mass. Okay, so you can see in this one, here it will be oven or capillary column. So this is a carrier gas, usually helium. So when the sample is injected in this oven, it will break down. So the mixture will break down. The compound will break down into mixtures and it will go to the mass spectrometer. There, depending upon the mass, there will be a library or magazine where it will be matching with what compound it is there. Okay, so we can find what all uh, molecules or compounds are present in the big sample. Okay, so that is why we know what are constants are present here. So this method is used for that. So we started with GCF itself, our green cutting fluid formulation. We found that there are different chemicals. Okay, this is from the additives we have used. Okay, but when we used the commercial one, there are many peaks. Okay, associated with this lubricant. So we found that there are phenol, there are trichloroacetic acid, different hexadecane. Okay, naphthalene are present in the commercial cutting fluid, and we found certain chemicals are present in the green cutting fluid also. Okay, so we find that a number of chemicals found to be toxic present in both GCF and CCF in this method. Okay, but the GCF showing extremely safe levels of toxicity in OECD 203. That is the test we done. Okay, so that means the we haven't reached the toxicity level, even though there are certain compounds present, it is not toxic to the environment. Okay, but whereas for the commercial cutting fluid, the concentration of the toxins is so high that it is highly toxic. Okay, so they have added beyond a certain limit. So central concept of toxicity is that it is dosage dependent. Okay, so the if you see the dosage of CCF, it is highly toxic. Right. So once we did the toxicity evaluation, now we have to go for the corrosion test. Okay. So here the corrosion can come from the concentration of metalworking fluid. It can come from the dissolved minerals and ions in that one, and the chlorine content in the solution, water quality, and the pH level. Okay, as I mentioned, water quality means there will be different area, different mineral composition will be there in the water. So it is preferable to go for DA water. Okay, and the corrosion is nothing but it is the disintegration of materials by reaction with environment. So we need to add additives that inhibit the water to the surface contact. Basically, it is accomplished by these polar molecules. Okay, in these additives, that what it will do is it will get adhered to the metal surface or by leaving a residual film coating. So this will protect the surface from corrosion. Okay, this corrosion protection principle is by blocking oxygen or moisture from the metal surface. So again, this is according to the standard. Okay. So we have corrosion test according to ASTM D4627. Okay. So this test was done to see whether a lubricant is corrosive or not corrosive. Okay. So we can see in this picture here there are Petri plates. Okay, with filter paper in it. So Petri plate is, I think you are maybe familiar with chemistry lab. There you have this kind of circular plates. Okay. In that we'll be keeping that filter paper. On top of that, we'll be keeping 4 grams of cast iron chips. Okay. You can see the cast iron chips are placed. Why cast iron chips is because they are more chance of corrosion. Okay. Susceptible for corrosion. Okay. So we add this 4 milligram of cast iron chips here. Right. Now we will introduce our cutting fluid or the formulated lubricant. So 5 ml of lubricant we will be adding to the each Petri dish. Okay. Then after 24 hours, we will see whether there is any stain mark on the filter paper. Okay. So that is qualitatively we can say whether it is corroding or not. Now, how will you tell whether quantitatively there is corrosion or not? Is by weighing. Okay, so there is a weight loss, right? If there is a corrosion happening, what will happen there? Metal turn to be oxide. Okay, so when you wash with acetone and water, what will happen is these corroded particles will get removed, right? But you know the initial weight was 4 grams. Now you know what is the final weight. So if you take the difference, you will get the loss in weight. So quantitatively also you can tell whether there is corrosion taken place, and qualitatively by seeing these filter papers, you can tell whether there was corrosion. Okay. So these are the results from that one. So you can see the stain mark in the filter paper. So you can see the 1 6 is GCF and one also is another commercial. First of all are sorry, 7 is water as a control. Okay. 1, 2, 3, 4, and 5 are commercial based cutting fluid. Sixth one is GCF and seventh one is control. That usually will take the water. Okay, water, water we use for this preparation of this lubricant. The same water will be having as a sample just to see how the corrosion aspect is. So you can see the corrosion effect there. So sample one or corrosion, cutting fluid one and the GCF was highly resistant to corrosion. Okay, so this is after 24 hours according to standard, but still we kept for some more days to see whether there is any change. Right, so this is after 7 days. So GCF showed less corrosion in comparison to CCF with the ASTM D4627 method. And these are the results from corrosion data. Okay, corrosion data, I mean the weight loss, initial weight we knew, and when we weighed second time after corroding and removing the debris or the corroded particle, there will be a weight loss in milligrams. Okay, so here I would say this is a tricky part. Why? Because when you are washing with acetone and water, there is a chance that you may flush away the chips also. So this test should be repeated or replicated for 4 to 5 times to get the right readings. Okay, you should be very careful in doing the weight loss method. But this qualitative method of seeing the stain is very much effective. But if you want some quantitative results, you have to go for this weight loss method. Right. I told about toxicity. That is only covered one part of being a lubricant, bio lubricant or eco-friendly. Now we have to see whether the bacteria is growing in that one or not. That is critical here. So the microorganisms can foul this whatever growth happening in these cutting fluids. This can foul the cutting fluids. In industry, they call it as Monday order. So Saturday or Sunday they have this holiday. Then they come on Monday, they will get a bad smell. So they call it as Monday order in Monday smell in industry. Okay. So they interfere with the desired qualities. They'll give objectionable odors. They may contribute to dermatitis, skin infections, etc. And it can even corrode. Metallic surface can get corroded. So when once we see through the literature, we found that these bacteria can come into the human by touching or inhalation or many other ways during machining operation. Okay, so basically, mostly the worker or the layman who is operating the machine, they are unaware of the cutting fluid drawbacks also, okay, or disadvantages. They don't know what will be the aftermath, so they may get these diseases due to the prolonged exposure. So we found the major pathogens for bacteria are E. coli, Salmonella, Pseudomonas, Staphylococcus. Okay, these were the major bacteria that were present in cutting fluids. Okay, they are classified as either gram negative or gram positive. Gram negative or gram positive doesn't mean that they are less uh, dangerous or not, but both will have its effect on human beings. Okay. So how will you classify whether it is gram negative or gram positive? This again is we can have different tests. Okay, one is stain test. Okay, suppose you have don't know what bacteria, whether it is gram negative or gram positive. There is a crystal violet stain test. Okay, so you put this violet stain on the bacteria sample in the petri plate. Okay, then what will happen is you have to add iodine. So this is a treatment so that if it is thick layer. For example, gram-positive bacteria will have a thick outer layer or peptidoglycan layer. Okay, so if it is a thick layer, this color will retain here. Okay, on the outer surface. Whereas for a gram-negative bacteria, there is very thin peptidoglycan layer. Okay, or the outer wall layer. So what will happen? This color won't retain here. Okay, so once you decolorize or you wash with ethanol or alcohol, what will happen is this color, initial color you applied, will stay in this gram positive but will get removed from the gram negative one. Okay. So now if you apply a counter stain, safranin, what will happen? The gram positive will still retain the violet color. Okay. But the gram negative will now become the safranin. Okay. This counter stain color. So with that, we can find whether it is gram negative or gram positive. So these are some tests done just to classify. If you don't know the bacteria, just to start the initial studies. Okay. Then for our studies, we chose E. coli, Staphylococcus, Salmonella, and Pseudomonas for the cutting fluid. So why? Because if you see in literature, this E. coli is having different effects such as urinary tract infection, meningitis, etc. And Staphylococcus is having food arthritis, food poisoning, and different other diseases. Similarly, Salmonella can cause typhoid, and Pseudomonas can cause skin and soft tissue infections. So now the question was how to proceed to test with the cutting fluid, right? So we had two ways. One is take the sample after machining, okay, or from an environment where there is chance of getting bacteria, okay. So that sample we can collect and then we can study whether the which all bacteria are present in that one. Now the challenge there is suppose if you formulate a lubricant and we are using in a different area, okay. So this bacteria can come from environment, can come from contact. Okay, so it is not very specific with the lab or the environment. Okay, it can change with place to place. Second option we took is to inoculate the bacteria. That is, prepare fresh cutting fluid or lubricant. To that, introduce the bacteria and check whether the bacteria is surviving or not. So second method is more appropriate. Why? Because we can put any bacteria and check whether the bacteria is growing in that one or not. The first one depends on the environment. Okay. Here we have the second one. It is like a holistic approach. So if you take this lubricant to any area, you can tell whether the if so and so bacteria is present, will it grow in that system or not. But we did both. Okay. We started with this controlled environment. We supplied this lubricant to the known sources and we got it after machining and we studied. And this also we did right side. We prepared fresh emulsion and inoculated this bacteria and see whether it's growing or not. Right. So there are different cultural techniques available. One is DNA based or plating method. Okay. So DNA based are good, fast results, but it's like PCR, polymerase chain reaction test. But only issue is it is expensive. So since we had the culture technique, plating culture techniques available in our laboratory, we gone forward with the plating technique. Okay, so this is the agar medium. So I'm not going to the details of the preparation. In short, I can say this medium is what this bacteria will professionally grow, okay, or easily grow, so that this environment will have yeast extract and different compounds for the growth of bacteria. So this agar medium is required for the growth of bacteria once it is present. Why we are allowing the growth of bacteria is to see which bacteria is present or not. Okay, so to enhance the growth. Okay, so this is a procedure. So what we'll do is we have the samples from the machine environment, right? We have the concentrated sample. Now we will dilute. Okay, serial dilution will be done. And on the Petri plate, we have the agar medium, what I was telling here. So already prepared. Okay, onto that, we will spread our cutting fluid or the lubricant and we will see whether bacteria is forming or not. Why we are doing the serial dilution is because if you take the first concentrated one, there will be a lot of bacteria. Okay, so we need to do the serial dilution so that we can get a countable number. Then we can see how much is there. We can count back anyway, but if it is lot of numerous present means we can't count. So for that one, we are going for the serial dilution. So you can see these are this way it will form. Even though after serial dilution, you can see the number of colony forming unit. Okay, number of bacteria cells. Please remember these are one. This is one colony. It is not one bacteria. In that colony, there will be hundreds or thousands of bacteria present. Okay, so we combined with different cutting fluid and GCF, and this is the phosphate buffer solution or the agar alone. Okay, so here no bacteria is there. Why? Because we didn't apply any lubricant to that agar. Okay. So we'll have a number count. Okay, so you can see TNPC means too numerous to count. Okay, so with the LB agar, we are checking whether positive bacteria is present or not. Okay, so we'll count the bacteria here and see how many colonies are there. So depending upon the serial dilution, we'll have the order. We'll just multiply and see how many bacteria are present in that particular or colonies are present in that particular sample. Okay. So the we did for gram positive and gram negative bacteria. Okay, so the interpretation was the different samples of the cutting fluid tested for microbial growth on LB as well as SS agar. LB means Luria broth and SS means Salmonella Shigella agar. Okay, so these are agar for both positive and negative bacteria to grow. So what we can tell is that commercial cutting fluids, few are giving good results. Okay, why? Because they are having highly toxic components. They have added as biocides. We have seen limonene, phenol, naphthalene, and longiflonextrine high levels in the commercial cutting fluid. That may be the reason why it is showing better results. So this proves that the high toxicity of commercial cutting fluid inhibited the growth of the microbes. Okay. Then the second method. Okay, here the second method is to take the fresh emulsion and to that we add the species, non-species and check whether the bacteria can grow in that one or not. Okay, so you can see this is graph results for that one after 24 hours and 48 hours. Okay, so you can see here GCF is the sixth one. Okay, you can see there are, this is one drawback we need to address. Okay, few cases you can see the GCF is not performing as good as the commercial one. Why? Because whenever we have a mixture of vegetable oil and the natural additives, there is chance that bacteria can easily grow. So that is one thing we need to find a natural inhibitor or biocide that can counter this effect. So this is one part we are still addressing. Okay, bacterial effect. You can see the performance of GCF and other commercial cutting fluid. Okay, then second part or the third part rather, I would say it is biodegradability part, right? As I said in the beginning, biodegradability means how well it can decompose, okay, how fast, okay, either by enzymes or by chemicals. So it is the ability to of a product to break down into smaller compounds, eventually to carbon dioxide, water, and oxygen. So again, to see whether a lubricant is biodegradable or not, we have different methods. We can use same equipment such as GCMS. We can go for BOD, COD technique, or different standards are there. So here, artificial aging, such as okay. So here we gone for the BOD, COD technique. Okay, so that is biological oxygen demand and chemical oxygen demand, right? So chemical oxygen demand is nothing but here, uh, in short, I would say we are exposing this lubricant to a chemical environment, okay, with acid, etc., so that the compound is getting breakdown using oxygen. Okay, so what will happen is the lubricant, whatever oxygen is present, that will get consumed. Okay, and this chemical breakdown happens, and it will completely get broken down into similar compounds. Now, biological oxygen demands means biologically we are decomposing. Here we will use enzymes. Okay, so here basically bacteria only will help in degrading. Okay, there is no chemical degradation here. So obviously, biological oxygen demand or the will be lesser than chemical oxygen demand, right? Because full oxidation may not take place if it is bacteria. So here the sample is taken in airtight bottle and kept at 20 degrees Celsius for 5 days. Okay, so the dissolved oxygen content is determined before and after 5 days. Okay, so here if there is a reduction in dissolved oxygen, that is because of the bacteria. Okay, use the oxygen to degrade the or decompose the lubricant. Here in this case, it is activated. Okay, so we'll keep this in high temperature and chemical oxygen demand. We'll keep this in high temperature oven and we will have these acids to degrade. Okay, so once you got the COD and BOD value, okay, so we'll, that is nothing but the measure of oxygen before test and after test. Okay, so according to the standard, if the BOD to COD ratio is greater than 0.5, it is biodegradable. Okay, and if it is in the range 0.3 to 0.5, it is low action or biodegradable. And if the BOD to COD ratio is less than 0.3, it is non-biodegradable. And we found that for BOD to COD ratio for GCF is zero point 0.6, it is having good biodegradability, whereas for the commercial cutting fluid it is 0.29. Okay, it's well below zero point 0.5. So summary from the initial synthesis part is this: the whatever we formulated from coconut oil based cutting fluid, it was stable according to the DLS and pH stability test. Okay, and the CCO has shown high toxicity levels. We tested in fish toxicity, fish embryo test, and skin cell viability, and the corrosion test also we have performed, and biodegradability tested shown GCF as biodegradable. Okay. So even though we have all these good properties, now the challenge is whether it is performing good in the machining environment. So we did drilling and turning experiment to check whether it is giving good results or not. Okay. So this again, usually how we measure this effectiveness of a lubricant in machining is by measuring the cutting force involved, okay, or the friction involved in machining. Okay. So I'll just skip these things. So these are the tests. Okay. So here this is the basic machining setup. Okay, so we have the lubricant or the cutting fluid here, and we do the drilling test and see how much force and torque is getting generated. So this is a universal milling machine. Okay, so we perform drilling in this machine and see with MS mild steel and aluminum material with stained HSS tool to see how much is the friction force and torque associated. So this was the procedure. Okay, so we drilled 30 blind hole and we sectioned it and seen. So we got the force values from the dynamometer, which is kept in this one. Okay, so this setup is having a dynamometer arrangement that will give the force and torque measurements. And if you section or cut this piece and see, and we can evaluate the surface finish of the drilled holes using different cutting fluids. So here we could find that our cutting fluid is giving comparable results with the commercially available one. But again, we couldn't get a clear cut distinguish between how well it is performing. Okay, so then we tried to measure with turning experiment. Okay, so here again this is we have used mild steel and aluminum. We have the dynamometer, so the tool is having a dynamometer setup. Okay, so this will give the tangential force and feed force. Again, what we found here is it is giving comparable results, but we couldn't get a clear-cut image of how well it is affecting. Why? Because these both we are measuring the force, how much friction is getting reduced, we can't measure by these setups. Okay, but if you compare the values of friction, sorry, torque and force values, we'll come to know that the beginning cutting fluid is performing equally or comparatively better than the commercial cutting fluid. Okay, so these are some of the observations from this one. Okay, so the repeatability test was less. Why? Because when we are doing this test, if you are calculating friction from this one, it won't give good results. If you are comparing force and torque, we can tell it is giving GCF was performing equally good with the commercial cutting fluid. Okay, so in some cases, better surface finish was found for green cutting fluid when compared to dry and commercial cutting fluid. And by using cutting fluid, we can improve the surface finish and prevent the corrosion of the workpiece and tip. Right, I will skip the tribology part. Okay, tribology, as I mentioned, this is to evaluate the friction and the wear properties of the cutting fluid. So this will give a better idea how the friction will be there for the lubricant. So this is a inverted pin on disc setup. So if you are rubbing a pin on a disc, okay, in normal environment, what will happen is you will have a friction disc regime. Okay, and suppose if you introduce a tool that is really happening in machining, you can see that friction is getting shoot up. Okay, so you want a lubricant which is performing good in this area. Okay, it is not here during machining. We are having machine tool interaction. So new surface will be generated and the lubricant should be effective in this regime. So that is what we studied in this using this equipment. So you can see normally in a pin on disc, you can see you can't clearly distinguish okay which lubricant is performing better. But with this one, this setup, we can have a clear distinguishing of which lubricant is better. Okay, so that is why this machine is unique in testing lubricity or friction or tribological aspect of a cutting fluid. I'll just skip these slides. These are the results from machining. Okay. So we made a portable version of this one also, what I have shown. So this setup, we can keep it in any machine, late machining, and we can study the lubricity effect. Okay. So we did some tests with that also. So that will give, so this setup is in situ results. Okay. You can take it to any lathe and test how much is the friction incorporated while machining using any lubricant. Okay. So you can compare any lubricant with this setup. You can see our lubricant also we have tested in this one in different feed and speed parameters. Okay. So observation I would say is that whatever green cutting fluid which is prepared gave better performance in terms of coefficient of friction and roughness. Okay. And the performance of GCF was stable and efficient with variation in the cutting speeds, which gives a thrust for further study, analysis and improvement. Okay. And why this cutting fluid is giving good result is because of the tribofilm formation. Okay, that the results I have not shown here. That is why because it is the formation of metal carboxylate layer. Okay, so whenever there is a metal lubricant and interaction and high pressure interaction, there will be a metal carboxylate formation that will reduce the friction. So since I was not explaining tribology part, I couldn't put those slides here. Okay. So to make perfect choice of fluids, it is important to consider not only the fluid performance characteristics, but also we have to see factors such as waste treatment, how the disposal is taken, how the fluid life is, resistance to microbial attack, etc. Okay. So to conclude, I would say petroleum-based commercial cutting fluid, whatever we studied, we found that they are giving good tribological result as well as machining result, but they are not eco-friendly, right? Whereas for cutting fluid derived from vegetable oil base, we studied with different oil, but here the study is shown for coconut oil. The results are good and it is eco-friendly. Okay, so BCR meets many of the characteristic properties or specifications of commercial formulations and even exceeded in the ecological point of view. So, in addition to the base oil being eco-friendly, what we took care is that all the necessary ingredients that is going to the formulation should be eco-friendly and sustainable. So that is what is unique with this work. All the ingredients we chosen was tested for toxicity. Okay. So this will eventually reduce the disposal cost and all. Okay. So thus metalworking fluids, disposal cost of hazardous waste, the cleanup cost of soil and water petroleum consumption can be reduced. So nevertheless, this formulation is good basis for further development and utilization of vegetable oil as a better, better metal working fluid. Okay. So as I told, we had certain objectives targeted. So we could develop a sustainable eco-friendly cutting fluid following the closed loop concept of sustainability, that is covering toxicity, stability, corrosion, and other characteristic aspects. And we studied the machining properties, and evaluation was done, typological evaluation also was done using tool chip tribometer and light tribometer. And we could develop a portable version of this tribometer. Okay. So I will, this is, so what I would say is this, what I have shown till now is the cutting fluid aspects. Okay, so cutting fluid is one of the classification of lubricant. Okay, so if you see in history, if you see in mid 19th century, so there initially it was mutton fat or goose greases or crude oil from sheep. Sheep means that time the naturally occurring when seeps through the environment, no gaseous, that is known as seep. Petroleum seep is a place where natural liquid or gaseous escape to the Earth's atmosphere. Okay, so those were the beginning. Then came demand in all machining as well as manufacturing areas, and it's not only metalworking fluid or cutting fluid. Okay, all lubricant is having the same story. So they are good in their respective aspect, but they have certain drawbacks, such as when it comes to in exposed to environment, it is having hazardous nature. So there are different eco labels available. Even India, we have eco label, but nobody follows that. Right. So European Union, they have strictly told there should be limit in concentration of the chemicals used. So there are different criteria. Okay. So basically, okay. So I'll stop here. So the benefits of biolubricants here is that it is developed from renewable sources. It is readily biodegradable. It is non-toxic to humans and aquatic environments, and inherent lubricity properties there. If you take a mineral oil and vegetable oil having higher lubricity. But only issue is there, it is having uh, low oxidation stability and high power point, and the production cost is higher, and edible versus non-edible oil issues like such as in India. Okay, so I will will stop here. Some more slides are there. Okay, right. Okay, rest are related to the chemical classification. Okay, so I think it is, you may get bored if I tell the chemical aspects. Okay, how the modification. Basically, if you want to use this lubricant in other areas such as engine oils, you need to have some chemical change. Okay, so that is nothing but we have to play with the structure. Okay, we have to go for chemical modification of vegetable oils. Okay, so that can be esterification, hydrolysis, and epoxidation, and different methods are there to get the advantages of this vegetable oil. Okay, these are all addressed just to overcome the drawbacks of the challenges of biolubricants. Right. Okay, so thank you everyone for your kind attention.
Thank you, sir. Thank you very much, sir, Dr. Suvin. So that was a nice presentation, more illustrative and elaborative, and
Sorry,
it's a very detailed presentation
I
on
will try to.
green lubricants,
Right.
and perfectly suits to our title, Sustainability Engineering.
Yes,
So
thank you.
now the entire world is looking forward to have to fulfill the motto like live green, stay green, looking always forward to achieve a green conditions for the sustainable and eco-friendly conditions of the world. So definitely this is a trendy topic. Would like encourage almost all our participants, those are working on this particular area. This could be of a great help and could be a very great resource for most of the participants, those are working in this area. And many researchers are doing on the same work. So this detailed presentation would definitely help them in enhancing their skills and definitely it would pave a very good path to these researchers in enhancing their skills, and people those are looking forward to choose an area in this green lubricant and tribologies, and definitely people would choose this. Thank you very much, sir. That was a nice presentation, Dr. Suvin.
Thank you very much.
And we
So
got like
actually, I
few
was,
questions, sir.
yeah,
Suvin,
sure,
sir,
sure. Yes.
are there in a question and answer session.
Yeah,
So
please, sir.
let me tell you, like we got one question from Dr. A. Chandrasekharan. What is the evaporation rate of eco-friendly lubricants at various temperature?
Actually, I would say I have detailed study on metalworking fluid. Okay, so there we found that Only 5 to 10% is there if you are working with mild steel at an environment at a cutting zone temperature of around 600 to 700 degrees Celsius. So basically it is water-based emulsion. So 95% it is water. Okay, 5% oil. So even though there is high temperature, it is in the minuscule area of machining zone. Okay, so we found only 1 to say less than 5% evaporation rate for metalworking fluid. And related to other lubricants, I don't have a detailed data to explain. But with respect to cutting fluid, I would say 1 to 5% what I have observed during machining.
Yes, sir. That's very nice, sir, Subin, sir.
Yeah.
And we got one more question, like
Yes.
which emulsifiers were used as emulsifier 12, etc. Can we use surfactants?
Yes. Actually, I can't detail tell about the emulsifier. Why I given the code is because it is under patent. Okay, but I would say it is food grade emulsifier like TN85, TN80. So these
Yeah.
are food grade emulsifier which you can easily find it from literature. Okay, so here emulsifier is basically one surfactants only. Here why we use this specific emulsifier is why, because it suited our base oil, coconut oil. So whatever base oil, food grade emulsifier we choose, and as I told, it may not be, suppose for whatever I have chosen for coconut oil may not be good for say castor or neem oil. Okay, you need to do that HLB test with the Griffin method and select the proper emulsifier for that. Whatever suitable for coconut oil may not be suitable for other base oil. So it is starts from there. But I would say it is TN85 in that category. Basically, it's oleate or stearate family you can, or palmate family you can look into. Okay, for getting the food grade emulsifiers.
Yes, sir. Very good, sir. And there's one more question from the same Professor Kaushik Nath. Is there any chance of foaming in the oil-water emulsion? Does it affect the lubrication efficiency? How to overcome this?
Yeah, that is there. Actually, deforming agent is there. I would say if you go for a field test, then there is certainly a chance of foaming. What we did is limited, because when we do it in an laboratory scale, or even if you go give an industry for a limited time, they won't be using as frequently as how they usually use in industry. Okay. So in our labs and machine shop, we didn't have that much frequency of operation. So we didn't found this foaming issue. So we didn't add any deforming agent as such. But as you told, it's rightly, I would say it is correct. If you go for field test for continuous use, such as in where there is where the machine is running continuously, there you need to add these deforming agents. You are right in that.
Yes, sir. Thank you, sir. I hope Dr. Kaushik Nath might have received a good answer from the speaker. If you have, sir, Kaushik Nath, sir, if you have still any doubts or something else, you may convey to the speaker straight away. We will provide you with the contacting details and all. Thank you, sir, Kaushik Nath. Sir, we have few more questions from Dr. Krishna G. Why zebrafish only is used in toxicity studies? And one more another question from the same person: why LC50 studies and results taken at 96 hours?
Okay, yeah, right. Good question. So, as I told, it's not only the zebrafish. We can use guppy, platy, and I would say there is a 6 or 7 fishes are there which are according to the standard we can use. So again, in the standard it is mentioned it is should be where easily means you can easily get it. Okay, so one option was that. And to be specific, why zebrafish is because among all the fishes which their standard is telling which we can use, zebrafish is the model organism which is being used in any what is the microbiology studies. Why? Because the structure is well known. Okay, it's a transparent fish and the organs are well studied. So if any change in the organ or defect in the organ can be easily, there is a magazine or literature available. We can easily compare where there is any damage happened to the internal organs or not. And also according to the studies, 60 to 70% of genes which are present in humans are present in zebrafish. So that is why it is known as the model fish or model fish organism. Okay. So in microbiology, basically there is for toxicity test, they will start with sometimes plant organism also. There is a standard what you call model plant that is called Arabidopsis thaliana. Okay. Similarly, in fish toxicity, this is the model organism. That is why we gone for zebrafish. And even in drug studies in microbiology, they go for the zebrafish to see whether any internal organs are damaged or not. So, but I would say for just to see whether it is toxic or not, we can go for other fishes also, no problem. Okay. So zebrafish we chose because of the availability as well as the since it is a standard organism or model organism. Right.
Thank you, sir.
And
That
second
was a
question,
very elaborative answer by Dr. Suvin. Sir,
yeah.
we have a last question from Vijayalakshmi Sakar. Her question is like, sir, why you have chosen only fishes? We got also have a sources of potatoes and other vegetables. Also,
Right.
we can extract instead chemicals.
Right.
So that's a question.
So why fishes is because eventually this lubricant will end up in pond or the water source. Okay. So we, if it is in environmental studies, I didn't present that results. We had results from this model plant also. Okay. So this plant, which when we expose this lubricant, they were not even growing. Okay. So that results is one level. So it is like a step by step. Then we went for the fish toxicity, then for the skin cell viability. Why again? Why pond is because this whatever lubricant, the improper disposal is a key issue. Okay, so that eventually will lead to the aquatic toxicity. So there, the major candidate is fish. Okay, if the fish is getting exposed to this toxic content, eventually it will come to us in the form of food. Okay, or other ways. So that is why we chose fishes. Okay, so that is a standard procedure. We can obviously do with other plant or setups, but this is why we went for this fish toxicity. And we did for fish embryo also. Nowadays people prefer fish embryo because we don't want to kill the fishes, right? So more fishes are killed if it is fish toxicity test. So we are going for fish embryo test. But rightly told, we can go for plant level also, but this is different levels. So if you do fish toxicity, we can authentically tell we did this test also, which will address the aquatic toxicity also, right?
Yes, sir. Thank you, sir. That was a very illustrative answers given by Dr. Suvin. Like, hope all participants might have enjoyed this session and received good answers from the Dr. Suvin. And I
Right.
request participants, if you still have any doubts or queries, you may post the questions on the group that can be forwarded to Dr. Suvin, and we'll come
Sure,
back to you with the answers as soon as possible.
sure,
Thank
sure,
you
sure.
very much, sir,
Actually,
Dr. Suvin, for being
yeah,
with
thank
us.
you.
And once
Yeah.
again, I would like to extend a heartfelt gratitude to Dr. Suvin on behalf of Department of Mechanical Engineering, Geetham School of Technology, and Geetham Management. And also from AICT Atal Academy, we extend a heartfelt gratitude to Dr. Suvin for sharing his valuable knowledge to all participants and this research fraternity. Thank you, sir.
Okay.
Thank you very much. Thank you once again, sir.
Thank you, Professor Asher, sir. Thank you very much for this opportunity for sharing my little experience. Okay, so I have a request. Also, actually, I was little fast in showing the slides, so many people may have not seen, may have many doubts also now. So they can easily contact me. Okay, through my email. Okay, you can share this in your group so that if there is any further doubts or clarifications needed, you can anytime contact me. Okay, thank you very much, sir. Thank you for this opportunity.
Thank you, sir. Thank you very much. Thank you.
Can I leave, sir? Okay.
You may leave, sir, please. Thank you.
Thank you very much, sir. Okay.
Thank you, sir. Ravi Shankar, sir. Good morning, sir. Professor Ravi Shankar, sir.
Yeah, very good morning, Rajshekhar.
Sir, very good morning, sir.
Yeah, is my video visible?
No, sir, it's not visible. Please give us an opportunity to have a look at you, sir, once. It's been a
Yeah,
long time.
yeah, just wait. Because I have to connect through phone then. Because my
Yeah, yeah.
laptop video is not working.
It's okay, sir. No problem. You can take your own time. I request all participants that our next session would be starting at 11:30. Meanwhile, we have the speaker online, so we would wait for you, participants and attendees. If you want to take a just leisure for a 10 minutes, you may please take and come back sharply by 11:30. The session is going to start exactly at 11:30. Thank you all participants.
Anything better.
Sir, now you are visible, sir. Sir, Ravishankar, sir. Ravishankar, sir, your audio, video is now visible.
What about audio?
Audio is also clear, sir.
Yeah.
Huh.
So I am accessing through mobile phone,
Huh.
whereas presentation is through laptop.
So you have logged in through too. So I'll change your name one slide. Right, sir.
ఇది అవ్వదు నాన్న ఇది పెడి
Now it's good, sir. Sir, Ravishankar, sir.
Yeah,
So
one
you're
minute,
ready
sir.
with?
How are you?
I'm fine, sir. How about you?
Fine. Just a minute.
Okay.
And I think
So, sir, you got 2 logins.
ఏం నాన్న ఏం చేయమంటావు చూడు ఒకసారి వచ్చి
రానివ్వండి, sir.
ఏండి ఏమన్నారు
Let him come and sit and join. That's not an issue. Come. Session is not yet started. Kids usually they are curious to.
అవుతున్నారా
Yeah, Rajshekhar. Rajshekhar?
Sir, I'm here.
Yeah, how are you?
I'm
How
fine,
the
sir.
things are going on?
Going on, everything smooth.
Then when you are coming to Vizag?
It's again probably Pongal, sir.
Pongal only.
Miru, are you going
How
regularly to
frequent
the
you are
college?
coming? From Monday onwards, sir.
Monday onwards regular, okay.
Uh,
We have been attending college regularly since August 1st onwards.
Okay, fine. Is it compulsory or just out of your interest you are attending?
No, it's made compulsion, sir. It's made compulsion from our campus that everyone should attend unless until there is, because we have undergone that COVID test and all also. And some people found positive, been put in quarantine for some time and found negative and they're worked again. So the things would go regular at Vizag campus from 1st onwards then?
Maybe. But suppose if you find any 2 more COVID cases in Vizag campus, then again it will be stop.
So here we got around like 20 cases found at the time of testing.
Right, okay.
20 almost.
In campus itself.
Campus itself. And most of our faculty members and supporting staff. But now they
How
are
are
like
our friends, Janardhan, others, how they are?
Janardhan, they're all fine, sir.
Okay, fine. Venkatnath.
Janardhan.
And what about admissions this year? Mechanical.
Admissions, good, sir. Now we crossed like 1,000.
No, mechanical I'm talking about.
Mechanical was one session.
60 full?
Like 58 something it has come around.
Even in Vizag it is 70 or 80. That's all.
Now the trend of engineering is going down now. Specifically, the mechanical is also going down, sir. I don't know why. And
no opportunities, no. Everybody wants job after completion.
So, but this pandemic made the entire year as a dead year.
And I am happy to share that my son got medical seat. He is going to get, actually. He got
very good. Congratulations.
Thank you.
Now your 2 wards are doctors only.
Yeah, exactly.
So there should be at least a difference in make them to have different specialization.
Yeah, we will do it. But it is not in our choice, no. That is their choice.
Yeah. That's left to them.
Yeah.
Now how she is doing? Daughter is elder,
fine. Daughter is fine. And both are probably my son also may get in Andhra Medical College. It's not Rangaraya guarantee.
Okay.
Kakinada.
Very good, sir.
Then, so I may take half an hour, 45 minutes or 40 minutes like that.
Okay. So we will have some questions, like you try your level best to just clarify the questions. The rest of the questions would be forwarded to you by means of email or something. Then you can come back with the answers.
Yeah.
And anyway, we would also provide with you contact details if anyone looking forward to collaborate with you in this the area what you are about to present, sir.
Yeah.
So that could be done, right? How about our rest faculty at Vizag?
Fine, everybody is fine.
Everyone
but
is good,
no contacts for last 8 months now. We are not regularly contacted. I am going only on Monday and Tuesday.
Okay.
Weekly twice. But from Monday onwards, you have to go regularly.
And was there any measures or something, steps you have taken to invite students on campus?
We don't know right now. Because first they will ask faculty to come. Then if there is no problem, then they will call students, I hope so.
But we initiated inviting students on campus.
Whether they are coming, are they coming?
No, 2 weeks back, around 65 students shown willingness to arrive at campus. But we made required arrangements for them, like tents and this quarantine. They have to be in quarantine for the first 14 days and should undergo isolation and all. But no one has reported, sir. And then later we inquired why you guys, after showing willingness also, why you unable to attend. Then they mentioned saying no, sir, we thought of coming. Then our parents are afraid. Then we will take little more time, sir. Anyway, we are doing good at online classes also. Do you need that our presence is required on campus during this critical situation? Something they told, right? Okay. We are not here to insist you. It's up. The choice is left to you.
Okay.
So we don't have not even a single student on campus, but the faculty members are attending regularly.
Okay. Anyhow, some research is going on, it seems. Faculty coming means some research. What about your work?
Going on, sir. This time made critical. Otherwise, I would have a little advanced step I would have taken.
You are still with the AU, no? Andhra University, no?
Same, sir. Same. Ramji, sir. Sir, it is 11:30. Shall we?
Yeah, please.
Let me give you a formal introduction.
Yeah.
And interaction with interaction you can have at the end with participants. I'll introduce you. Then you can start the session, sir. Right, sir? Okay.
Yeah.
Sir, will you please share your cover page of the presentation?
Yeah, green composite. That's all.
Yeah.
It is already shared now. Is it visible? No.
No, it's not, sir.
Then wait.
Ah.
I think it came out.
Yes, sir, it is visible.
Yeah.
Ravi Shankar, sir, like I'll introduce, and we have one more course. Raghuvamshi Krishna is there. I'll leave. I have a class at 11:45, right? I'll introduce you, and you may please go on.
Okay.
Dr. Raghuvamshi Krishna would be there with you, and
Okay.
we have also Santosh Kumar as a co-host, right, sir?
Okay.
Right, sir. Let us start, sir.
Yeah.
So once again, back to the second session. I welcome all participants and panelists to this second session of last day of 5-day faculty development program titled as Green Technology and Sustainability Engineering. And today for the second session, we have Professor H. Ravi Shankar with us. Ravi Shankar, sir, is presently working with Geetham University, Department of Mechanical Engineering as a professor, and he specialized in machine design. And he has done his PhD from NIT Warangal, Andhra Pradesh at the time, like when sir has obtained. Now, of course, it belongs to the Telangana state, right? So today we are very happy to have Professor Ravi Shankar with us for sharing his knowledge on green composites. And sure, this could be of a great help to all participants working on this area. So I would like to invite Professor Ravi Shankar to this 5-day faculty development program. Hearty welcome to Professor Ravi Shankar. Sir, we welcome you on behalf of Department of Mechanical
Thank you,
Engineering.
Rashekar.
Welcome, sir.
Thank you very much. I am very much thankful to the Geetham Bangalore campus for giving me an opportunity to present my little work, what I have done. I'm going to present right now. Green composites. Can I proceed, Rashekar?
Thank you, sir. Thank you very much. You may please start the session, sir.
Yeah.
Thank you.
First of all, I am very much thankful to the Geetham Institute of Technology Bangalore campus for giving me this opportunity to present green composites, which I have carried a little work. So basically, topic is green composites. Yeah, first of all, let us see what is a composite. Composite will have several advantages, which we have seen. Generally, fiber reinforced composite, polymer composites are the most highly valued materials, mainly because of these are the advantage of the composites, why they are using high specific strength, high specific modulus, coupled with extreme versatility and low cost. What is meant by specific strength? The specific strength is nothing but the properties per unit density is called the specific strength. So, though the absolute strength may be low, but the specific strengths are very high for the composites. So, this leads to reduction in weight of the structure. So, these composites are replacing conventional materials from almost all the engineering applications, from household applications to even aircraft structures, automobiles, and so on. So because of this high specific properties leads the composites usage more and more. And it is low cost also compared to other conventional materials. Therefore, these composites are replacing the conventional materials. But of course, every thing will have adverse effects and pro effects also will be there. Let us see one by one. So these are having, as we discussed, versatile applications, which ranges from aerospace applications and building structures, electronic equipment, packaging, and so on. Very versatile equipments are there for composites. And one of the most advantages with the composites are these are tailorable properties. Means in one particular direction, if I want any one particular property, I can make it suitable and I can fabricate the composites in that particular direction. So if I want strength in one particular direction, I can do it. If I want strength in different strengths in different directions, I can make it by changing the fiber orientation. This is also possible to have different. So it is. I can say it is. We can have tailorable properties. And what are the various different types of composites? This normally we are having metal matrix composites and polymer matrix composites are basic. And there is ceramic matrix composites are there, carbon matrix, carbon composites are there. There are so many matrices, but metal matrix composites and polymer matrix composites are the basic main uses are going to have. But compared to metal matrix composites, the utility uses in weight reduction and strength point of view, polymer matrix composites are predominantly replacing the conventional materials. So what these place more interest, more uses, polymer matrix composites. So what are the various polymer matrix composites? Are these polymers which we are going to fabricate the polymer matrix composites are generally petroleum-based thermoset polymers or thermoplastic polymers. Thermoset is epoxy, polyester, and thermoplastic is polypropylene, HDPE, PVC. These are thermoplastic plastics. So anyhow, these two matrix materials are being reinforced with the fibers, different types of fibers we are available, and these fibers, these matrices are reinforced with the different types of fibers. All these polymers are derived from the chemical synthesis of petroleum-based resources that are finite quantity. So that is, petroleum is finite quantity, and which have to take care of that. And the reinforcing materials are normally what we are using right now is synthetic fibers. The synthetic fibers are glass fibers, carbon fibers, Kevlar fibers are the synthetic fibers which we are going to use at current industrial uses we are using to use. And the main problem with the matrices are they do not degrade several decades after disposal the intended uses. Suppose if you finish the uses, if the function is over, I cannot dispose easily. That is the main drawback of these polymer matrices. So we have to address that problem. Span is become difficult and very expensive also. So it is very difficult to disposal of the products are very, very difficult with the polymer matrix. That is to be addressed. And these, when you dispose it, these are generally ending up with the landfills, causes a serious global environment problems. So this is to be addressed. And emissions during this disposing, emissions are very dangerous and major drawbacks of the conventional composites. These are the various drawbacks of these conventional composites. This is to be addressed properly. But recycling of these composites, suppose if you want to do, I don't want to dispose, I want to recycle it, again it is more expensive and it is also very difficult. So we need to have a look on this also. Then now the green composites has come into the picture. What is meant by green composites? Why it is taking more interest? Stringent government regulations, and then disposal problems can be addressed with the green composites. Rising oil prices is again because all the polymer matrices are petroleum based, therefore rising oil prices may lead to develop green composites. And then fossil fuels and growing environmental consciousness related to use of petroleum based products. And these are forced manufactured to seek friendly and sustainable materials that address the problems associated with synthetic composites. So because of all these green composites has come into the picture. So we have to see the possibility for the green composites. So the replacement of synthetic fibers with natural fibers. So there are some natural fibers are there like jute, sisal, some fibers are there which can replace the natural fibers with the synthetic fibers. In some of the cases, combining synthetic fibers and natural fibers with partially biodegradable natures are now also addressing a partially it is green composites, and some environmental problems can be solved with this combination of this hybrid. And we are basically now looking into biodegradable polymers. These biodegradable polymers are generally they are using now, but the problem is there are many industrial applications such as biomedical, food packaging, electrical appliances, waste composting bags, and other consumer products they are using for this biodegradable polymers. The problem with the biodegradable polymers are, though they are using efficiently in almost all the applications, their usage is only limited to the consumer products, where the properties are mechanical. The engineering applications of these biodegradable polymers are almost seldom found. You cannot find. So biodegradable polymers only uh, for only consumable products. You cannot use for the engineering applications, like engineering structural engineering applications. So we need to do something to enhance the applications of this particular biodegradable polymers. That's what we had done. A little work is carried out. So these biopolymers are derived from renewable resources such as polylactic acid, PHB, thermoplastic starch, cellulose. These are all biopolymers, which these are biodegradable. So better to use this polymer to have to enhance the usage of this engineering applications. And proteins, these are various. So you see this biodegradable is when you during degradation process, it releases the carbon dioxide and water, and then again it can use for photosynthesis. And the cycle is the degradability of this particular polymers are very suitable, can be used for engineering applications. Suppose if you increase the enhancement of the properties of the composites with this, then we can comfortably use for the engineering applications. At the same time, you can contribute a lot to the environment. So that is main area and focus of the research, to enhance the properties of this particular composites. Still now it is under research. So the present attempts are going on to improve these properties of this particular biodegradable composites. So similarly, natural fibers will have, so natural fibers can be used. Natural fibers will have potential advantage, sustainable and compared to synthetic fibers. So renewable character, low cost, low density, because these are the advantages of the natural fibers. And comparable specific strength, though it is not exactly equal to the synthetic fibers, it is comparable. Carbon dioxide biodegradability. But one more advantage with the biodegradable polymers, biodegradable fibers, are the energy required for producing natural fiber, MAT, including cultivation, harvesting, and fiber separation, amounts to approximately 70% of the energy required to produce a glass fiber mat. So that is so the energy required to produce these particular fibers are less compared to synthetic fibers. So therefore, these fibers are playing more and more interest. Researchers are looking on this to improve these properties, to enhance the properties of these composites for better usage in engineering applications. Though those are using, these uses is only limited to the consumer products. It's not in structural applications, it is not using right now. So a little attempt has been made to improve their properties in the present work. The mechanical properties, as we discussed, the mechanical properties of the natural fibers are quite lower. That is the disadvantage of the natural fibers. The mechanical properties are very less compared to glass fibers. So this is to be addressed. So you see once you can see the properties, jute, flax, ramine, sisal, coir, e-gloss, you see almost densities difference is there, but the properties, you see this strength, and this strength is very high when compared to this. So this is the drawback which is to be enhanced. So where these applications of green composites? We are using this as in packaging industries right now, automotive and consumer goods, where the loads are not that much important. Load carrying capacity is less. We are using this green composites. Restricted to automotive interior parts only. We are not using as a structural parts like power transmission devices. We are not using. Where the loads are coming, we are not using. So where significant mechanical properties are not prime concern, then these green composites are right now you are using. Automotive interior parts such as door panels, seat backs, packers, trays, headliners, dashboards, etc., we are using. So right now we are using these green composites. So for example, Toyota has developed ecoplastic polylactic polylactate and fiber composites they are using. And Benj is using 26 components, 23 cages made from natural materials. And Mercedes S-Class includes 27 bio-based composites. They are using weight 43 cages, which could have been higher when you are using conventional polymers or metals. So the weight is reduced, and these are only non-engineering application. That means where the mechanical properties are not that much concerned. So seat backs, package, it is subjected to very less loads. And Ford has used PLA-based, polylactic acid-based composites, which has currently being utilized door inserts. And floor trays, pillar panels, central, these are all right now they are using green composites. So this is these are the various taken from the net only. These are the various components that are fabricated with the green composites. That is jute, maybe jute, sisal, Kevlar, not Kevlar, sisal, palm tree fibers, wire. These are the fibers that is fabricated using natural composites. So what are the right now challenges? The right now challenges are, in spite of having numerous advantage applications of these eco-friendly materials, has been restricted to non-structural and consumer products where significant material properties are not required. So if strength is required, I cannot use. If damping is required, I cannot use this. If stiffness is required, I cannot use this. So it is only confined to non-structural engineering applications. So I want to enhance these properties. In order to extend the range of applications, biocomposites such as strength, stiffness, resistance to impact loads, wear resistance, damping capacity, and thermal properties are to be improved. This is the target of the present research. So to extend the range, the usage range, I need to improve some of the properties. How? So we can change the processing conditions. We can study the processing conditions. We can change the processing. We can study the effect of processing methods. We can change the fiber matrix interface properties, how they are going to react with each other, and how the moisture absorption capability of the natural fibers. So all this you have to examine properly, you have to study in a systematic manner to enhance these properties, to optimize this, and to improve these properties. In the present, what we have done, so we have considered the processing conditions and methods such as temperature and heating time. So if high temperature is used, there is a thermal degradation problem is there. If low temperature is there, insufficient wetting will be there. So both are problem for us. So there should be an optimum temperature, optimum heating value should be targeted. And then pressure, when fabricating the materials, high pressure may damage the matrix, or if low pressure, poor consolidation of the laminate. So these are the high pressure is also not desirable and low pressure is also not desirable. So have to come at an approximate value of optimum value of the pressure. And then fiber matrix interface is one of the another character which you have to look. So formed by combining, actually just a minute, sorry. So fiber matrix interface, biocomposites formed by combination of hydrophilic natural fibers. So natural fibers are hydrophilic and fibers and hydrophobic biopolymers. So this you have to address. So proper surface treatments are to be carried out to better fiber matrix interface between hydrophilic and hydrophobic materials. So this leads poor mechanical properties. So once if you treat properly the surfaces of this, then you can enhance the mechanical properties by enhancing the bonding between the fibers and the matrices. That can be one of the target which you can look. And then moisture absorption, of course. So this moisture absorption forms this moisture flows to the interface because of the micro cracks and may lead to decrease in the properties of the materials. Limits the biocomposites in engineering applications. This swelling of the fiber is due to moisture absorption to be addressed. Formation of microcracks in the matrix. This may be one more disadvantage. This moisture penetrates to the fiber matrix interface through the microcracks and results in the degradation of the fiber matrix adhesion. So this results in poor mechanical properties, leading to reduction in mechanical properties and affect dimensional stability. So these are to be addressed. So what biodegradable polylactic acid we have considered in the present work? We have carried out some work to enhance these properties. Biodegradable polymer polylactic acid and the jute fiber with the density of 1 has taken in the present work what we have carried out. So mean tensile strength that is calculated when the fiber pull-out test is 432 Newton per mm square using Instron tensile testing machine. Single fiber pull-out test, we carried out the test and it is found that the fiber strength is, jute fiber strength is this much. So these are the physical properties and thermal properties of the polylactic acid, which I am going to use, which I have used as a matrix material. These are the density, glass transition temperature, and so on. So what we have done is we have fabricated the composite fabrication. These are the PLA, polylactic acid granules. The films initially prepared by heating and compressing with PLA granules at 170 degrees centigrade. So film thickness of 0.7 mm thick is fabricated, and then these films are stacked one on another. In between this unidirectionally stitched glass fiber mats are inserted in between, and these are stacked and held in a compression molding machine where the heating control elements are there. We can control that. We have fabricated the composites with the polylactic acid and the jute fiber, and the stacking was put compression molding machine equipped with the heating plates. And this is the compression testing machine, and this is the to fabricate the polylactic acid films. We have fabricated in these films, and the stack is pressed in the compression molding machine and fabricated the samples. So the assembly is heated and passed once the polymer has melted. So the heating time, the temperature is, this is one of the performance process parameters I can study. I can change the process temperature. I can change the process time. I can change the heating time. So different process temperatures and different results. We have done so many experiments, and we have concluded that the optimum values of the temperature and pressure and heating values. So this is the temperature where that has been raised and hold for some time, and then pressure is reduced gradually. Again, hold at this particular temperature. Again, it is cooled to the room temperature. The pressure maintained constant. So this is the process parameters what we have used. The assembly is heated and presented once the polymer has melted. The composite is cooled to melt the crystallization temperature and held at temperature for a measured amount of time this time, and then cooled to room temperature under constant pressure. So that's what how the composites are fabricated. Once the composites are fabricated, different temperatures, different levels, 1, 2, 3, 4. One is 170, 180, 190, and 200. And pressures is 2.5 megapascals, 5 megapascals, 7.5, and 10. Gradually increase. Heating time also changed. And cooling system. The cooling system is also, one is forced convection by using a fan, and forced convection with the fan speed is increased. And this is soaking time changed without any soaking time. Soaking time is changed, and natural convection is also used. So different process parameters and different levels are used, and different properties are evaluated using ASTM standards. Tensile and flexural and impact properties are analyzed. So these are the data that is for each sample, 170, 170, 170. These are the temperatures, A, B, C, D, different properties. These are the tensile strength. So for the Taguchi analysis, we have used the noise ratio, SN ratio, and so on. We obtained the better optimize the process parameters initially. Now, if you see the tensile temperature, the effect of temperature, process temperature on tensile strength, you see this when you're increasing the temperature 170 degrees, we got the highest tensile strength. When you're increasing the temperature, there is a degradation of the polymer and the properties are reduced. So therefore, the tensile strength is, because of the degradation of the matrix, the tensile strength is reduced. At the same time, pressure almost up to certain range, there is no effect of the pressure. And naturally, after increasing the pressure, the tensile strength is decreased. This leads to damage, formation of the microcracks in the matrix, and leads to decrease in strength. And similarly, heating time, when less heating time, you have the high tensile strength. When the heating time increases, the tensile strength going on decreasing. Because here laminar structure is disturbed, and we won't find any laminar structure when you're increasing the heating time. Similarly, cooling times will have a minor effect on these properties. So these are the various effects on the process parameter on the tensile strength. Similarly, the same result is obtained for the flexural strength. The flexural strength is also decreased with the temperature. So you can see similar result almost, only a little bit here. You can see a change, but almost remaining all similar changes. You can see pressure and heating values and the cooling systems and recrystallization temperature, soaking time also we can analyze this. But one, you can see this acts as if you are heating, if heating is slow cooling, we can use the granules are formed so that it acts as a stress concentrations. So therefore, the strength is reduced if the cooling time is increased. Whereas if the rapid cooling, the formation of the granules are very, very less, so it reduces the stress concentration. So thereby the strength, if rapid cooling, better tensile properties are obtained. Similarly, we can see the impact properties. The problem is the impact strength for cooling system is when you are increasing the cooling system, it is just reverse to the tensile strength. Just it is reverse to the tensile strength. The impact properties has given adverse effect with the temperatures and pressure and heating values. So after this, Taguchi analysis, and we have given the best process parameters for obtaining the better composite with the green composite. So if tensile strength is concentrated is our interest, so these are the process parameters that is recommended. If the flexural strength and tensile strength both are same process parameters are identified. Whereas if you want impact strength, a little bit change is there for the process parameters. So Rajshekhar? Hello.
Sorry, problem, sir. This is Raghuvamshi from Mechanical Department.
Raghu, is it audible? Is it audible?
It is audible, sir. It is audible. No issues. You can continue,
okay.
Sir.
Okay. Okay.
Thank you, sir. Thank you.
So these are the different process parameters which using Taguchi approach we have finalized, and these process parameters we use for further research. So one option is to enhance the properties. The best method is to control the process parameters. Once we decide the process parameter, these are the different process parameters what we have used. Once if you use the process parameter, the fiber matrix interface is to be enhanced to have the better properties. The different fiber treatments, fiber surface treatments, which enhance the fiber matrix interface, it has been carried out by using alkalization, treatments, alkaline treatments, and saline treatment 1 and saline treatment 2. Permanganate treatment, alkaline treated fibers were dipped. So these are the how we have carried out. The fibers were soaked in 5% of NaOH solution and then washed with distilled water until pH value is 7. And after washing, jute fibers were kept in hot air for woven for 5 hours and 80 degrees. Then we have taken that for fabrication. One set of composites are fabricated using alkalization samples, and different fiber treatments has been carried out. And again, the same properties are evaluated and all the tests are carried out for comparison. So what we got is with the saline 2 treatment, we got better properties. So this is tensile strength with untreated, less poor tensile strength. With saline treatment, we got very high tensile strength, an improvement of 35% in tensile strength. Similarly, a tensile modulus, which is nothing but stiffness of the composite, is increased by 38% when you are using saline 2 treatment. That is the so we concluded that the saline 2 is giving better results for treatment of the jute fibers. So when you are fabricating the green composites with using jute fibers and polylactic PLA, then saline 2 is advisable with the given process parameters combination which you got through Sagogia. So these are the different properties what we got, and these are the most recommended for the surface treatment. So that is because this when you are using the saline treatment, the fiber will become rough, and which is have a better mechanical locking with the surrounding matrix, and great bonding will be there with mechanical bonds, because stick slip motions can be arrested because of the rough surface, and the strength and stiffness is increased because of this rough surface. So therefore, saline treatments are giving better performance. But whereas if you see the impact properties for the untreated fibers are very, very high when compared to treated fibers. So it is going on decreasing. So impact toughness and fracture toughness is going to reduce. Anyhow, the toughness is also related to the damping. So if toughness is more, then automatically damping is more. So these composites cannot be used for the dynamic loads because the impact toughness is less compared to untreated. This is because the toughness is nothing but the energy absorbed. The energy absorbed up to failure is called toughness. So whenever cracks are there, debonding is there, cracks are there. So there is a stick slip motion. There is a relative motion between the debonded fibers and the matrix, and then this relative motion generates the friction. This friction absorbs the energy. The work done against the friction will absorb the energy that is caused, that is applied. So therefore, the toughness is more for untreated fibers because there is the most unbonded fibers are there, or fiber pullouts are there. This loose fibers and matrix will create a relative motion between the fibers and the matrix, which develops the friction because of the rubbing action, and the most of the energy is being absorbed and the reported high impact strength. So this is, though impact strength is required, but this type of impact strength we don't want. This impact strength is because of the debonding, because of the relative motion between the fibers and the matrix. This is to be reduced. So if I want to use for the structure for the dynamic load, the impact strength is to be improved for this material. Similarly, dynamic mechanical analysis is carried out. What is meant by DMA? DMA is nothing but dynamic mechanical analysis. Dynamic mechanical analyzer. Using dynamic mechanical analyzer, I can carry out dynamic mechanical analysis where the specimen is subjected to a harmonic force. The specimen is subjected to harmonic force, and correspondingly the stress and strain values are plotted. So there is always, because the composites or polymers are viscoelastic in nature, so there is always phase lag between the applied force and the displacement. Means if I apply a force at this instant, the displacement will cause after a moment. Suppose if I plot a load, the displacement starts after some time because of the viscoelastic nature of the fiber. So the difference between the point of application of the force, the time of application of the force, the time of response is called the phase lag. So there is always, for all viscoelastic materials, there is always phase lag between the applied force and the response. So this phase lag means the energy, the strain energy is nothing but stress into strain, half into stress into strain. The energy is nothing but the stress and the strain at this instant. But that strain at this instant is not because of this load. This is some other load, the strain is right now. So because of the phase lag. So therefore, the strain energy is calculated considering the phase lag, and that is plotted storage modulus and the tan delta value. The storage modulus is refers to the dynamic stiffness, whereas tan delta refers to the damping. Tan delta is nothing but the energy that is dissipated because of the phase lag, because of the hysteresis. What is hysteresis? Loss of energy because the stress and strains are not in phase. So that tan delta value will give the damping. So if you see this, for untreated value, the damping property is high here. So the damping and toughness, impact toughness is more for the untreated fibers. What is meant by damping? The damping are basically two types. One is viscoelastic damping, other is Coulomb damping. What is Coulomb damping? Coulomb damping is nothing but the energy that is dissipated because of the friction is called Coulomb damping. Suppose if I have a mass, if I have a plate here and one more plate is attached here, these two are in contact, then if I make it any vibration, it becomes dies out the vibrations because of the friction between the two plates. Similarly, whenever there is a loose fiber, whenever there is a debonding is there, the relative motion between the fibers and the matrices will contribute the friction, which is nothing but a Coulomb damping will come into the picture. Because of the Coulomb damping, tan delta will always give the material level damping. So therefore, it exhibits a lot of damping value. But this damping is not healthy damping. This is because of the damping, because of the loose fibers, because of the loose fibers. This is to be avoided. So though the damping is required, but not this type of damping. This is because of the Coulomb damping. Because strength is less, but damping is more, means that is because of the friction. Because of the friction, the damping is reported more. This is to be addressed and this is to be reduced. So that's what regarding this green composite. Then to increase this damping property, then we have gone for hybrid composites. The hybrid composites is nothing but polylactic acid. Again, polycarbolactam blends are used to enhance the impact strength and the damping property also to be enhanced using this particular. I have added at the cost of stiffness. So we have added polycarbolactam blends for PCl blends for, it is a biodegradable polyester. It is also a polymer, biodegradable polymer. So this is used as a blend for increasing the toughness and the damping. So previously the strengths are more, but the toughness and damping properties are less. So we have to address to increase the toughness and damping also at the cost of stiffness, but not that much effect. So without much reduction in stiffness, we have enhanced the composite damping capacity and impact strength using this PCl blends. So how we have done it, PLA is dissolved into PLA and PCl granules are dissolved into chloroform. And this chloroform solution is continually appropriate amounts, different weight fractions we have considered, and poured in on the jute mat, we have poured the liquid chloroform. After some time, this chloroform will be evaporated and only PLA, PCl will be left over. The solvent was slowly evaporated in fume soot at room temperature of 24 hours, and then the prepex are taken out. And once the prepex is nothing but a mat, the jute fiber mat prepack with this PLA and PCl. So these are stacked one by one, and again the same process we are used. It has been used to develop the composite with the hybrid composites. Now, if you develop the test for that, We carried out all the tests what we have carried out for the test. We have seen different weight fractions of the PLA and PCL. So PLA, PCL, jute fiber, the combination, different combinations, A, B, C, D, E, we have plotted, and we have seen this. The tensile strength is somewhat compared to this, it is reduced. But the impact, the work fracture is nothing but impact strength. Impact strength is enhanced a little bit without much affecting the stiffness. So these hybrid composites can be used for the structural applications. But right now, this is the area of research. Still, we can explore for all the process parameters, how does it affect on the moisture absorption is to be carried out. All the effects you have to see and to develop green composites further for engineering applications. Raghu sir, thank you very much.
Yes, sir.
Yeah, this is my topic. What?
Okay, sir. Okay, sir. I hope
what we have carried out. Based on this,
okay,
we have
sir.
published 3 journals on this. This
Sir.
is the work carried out by us, by our team. Rather.
Okay, sir. That was nice presentation. Thank you, sir. Thank you very much. I hope there are no questions from the participants.
Okay.
Participants, if you have any questions, you can raise the hand so that I can allow you to speak to speaker. If no questions, I think there are no questions, sir. Nobody has posted any questions.
Okay.
Okay, sir. Okay.
Okay.
Fine, sir.
Very much.
Thank you, sir. Thank you very much, sir, for accepting the
Actually,
invitation.
I asked to
Sir.
for 40 minutes. So
Yes, sir.
exactly 45 minutes. Okay, sir. Thank you.
Fine. Thank you, sir. Thank you, sir. Thank you very much. That was an excellent presentation, and it is a valuable information for the active researchers and faculty members for doing
Can I
the
leave, sir?
research in this field. Okay, sir. Okay. Thank you, sir. Thank you for your valuable time. Hello.
Sir?
Yes, sir. Yes, sir. You can leave, sir. If you can leave.
Yeah. Thank you.
Yeah.
Thank you.
Thank all the participants for their active participation. And I request all the participants to join the last session at 2:30 p.m. Thank you. Thank you all. 2 o'clock at 2 p.m. you can join all of you. Thank you all. You can take a small break, all of you. Thank you all.